Here's another electrostatics example problem. It's problem number 34 and a little bit more. I'm going to ask a couple of questions as I go along. A proton is placed between two plates that are attached to a 6-volt battery. The plates are 0.56 meters apart. What is the strength of the E field? First, let's draw a picture of the situation using a schematic. So I've got a battery at the bottom connected to two plates by some wires. They're separated by some distance, which is 0.56 meters, and that's a 6-volt battery on the bottom. So now I've got a picture to look at to help me figure out things. If I look at my givens on this problem, I can see the voltage is 6 volts, the distance apart is 0.56, and I'm looking for the electric field. Straightforward problem. I know that the relationship for electric field is going to be the voltage divided by distance, or I can write it as V is equal to ED. So 6 volts is equal to E times 0.56 meters. The E is going to be 11 coulombs. It's actually 10.7 something. With two sig figs, we'll go with 11 newtons per coulomb. So electric field is 11 newtons per coulomb. Now let me add a question to this. What does the electric field look like? So what I need to do is figure out the charge on each plate. And that's pretty easy. The side of the battery that the plate is connected to determines its charge. So the red line is the negative side of the battery, and the blue line is the positive side of the battery. So now I know which plate is positive and which plate is negative. Now, an electric field is defined as the path a positive imaginary test charge would travel. So if I put a positive charge in between these two plates, it would be repelled from the positive plate and attracted to the negative plate. So in this case, the electric field will follow that path of being repelled from the left and attracted to the right. So that's what the electric field will look like. Okay, so let's keep going. Let's add a few more questions. How much force would a proton feel in between the plates? Well, if I look at my givens so far, I've got the charge, and that's a proton, and I got that off of a constant sheet or maybe even Google. And the electric field, I know because I calculated it. I'm going to keep some decimals on that number because I'm using it as an intermediate calculation. And I want to find the force. Again, a straightforward calculation. F is equal to QE. So the charge of a proton times the electric field with all those decimals. And that gives me 1.7 times 10 to the negative 18. Remember, don't write it the way the calculator shows it to you. That's just texting you the answer. You need to write it formally as 1.7 times 10 to the negative 18 newtons. Okay, so let's keep going. Let's go with another new question. So here's all the stuff that I've already calculated. And the new question is how much work is done in moving a proton across the plates? So work is force times distance. The force is QE. If I just move my parentheses to be ED, Q's parentheses ED, well, ED I recognize as the voltage. So that's Q times V. So there's our work for going across the plates. Pretty simple enough calculation. So the work is equal to 1.6 times 10 to the negative 19 coulombs times 6 volts. And that's going to be 9.6 times 10 to the negative 19 joules. Again, don't write this the way the calculator shows it because it's texting you the answer. So write it the way it's supposed to be formally. Now another way to do this in a little more advanced form is you could just do EVs. So you could write it in terms of electron volts. So 1 proton is equal to 1 value of electron volts or 1 elementary charge times the voltage, which is 6. So this would have been 1 times 6 or 6 EVs. If you haven't been exposed to the EVs yet, don't worry about that.